nobody thought the ocean was this deep. So all of a sudden we've got scientists saying, why is that?
At the bottom of the Mariana Trench lies a world built to crush almost anything that enters it. Down there, the pressure exceeds 1,000 times what we experience at sea level. The water stays just above freezing, and sunlight hasn't reached these depths for hundreds of millions of years. By every scientific expectation, it should be one of the most lifeless places on Earth. But over the last decade, powerful robotic landers, high-definition cameras, and human expeditions finally reached its bottom. And what they found wasn't just a few strange creatures. It challenged decades of scientific thinking about life itself. But what shocked scientists the most wasn't the bizarre life. It was something deeply disturbing lying on the seafloor. So what's really living at the deepest point on our planet? And why did it take more than 140 years to uncover the truth? Let's dive in. The edge of survival. The Mariana Trench lies in the western Pacific Ocean, about 200 miles east of the Mariana Islands. It's a giant, crescent-shaped scar on the seafloor, created as one massive tectonic plate slowly slides beneath another. At its deepest point, known as Challenger Deep, the ocean drops nearly 10,900 meters, or about 35,800 feet. Now, here's something fascinating. The depth of Challenger Deep was first measured in 1875 by the British survey ship HMS Challenger. Using nothing more than a weighted rope, the crew estimated it at about 8,184 meters. It was humanity's first real glimpse into one of the last completely unknown places on Earth. Modern sonar later showed that the trench is actually around 10,900 meters deep. But even today, scientists don't agree on one exact number, because measuring the deepest part of the ocean is far more complicated than it sounds. Whatever the exact number is, one thing is certain: it's unimaginably deep. In fact, if you turned Mount Everest upside down and lowered it into Challenger Deep, there would still be more than a mile of water above its peak. Now the question is, at such an extreme depth, can life even survive? To answer that, we first need to understand one important concept: the hadal zone. The term was first proposed in 1956 by Danish marine biologist and oceanographer Anton Frederick Brun. Named after Hades, the Greek god of the underworld, it refers to every part of the ocean deeper than 6,000 meters, including the deepest trenches on Earth. And here's what makes it so remarkable. The hadal zone covers less than 1% of the global seafloor, making it one of the rarest environments on our planet. In many ways, it's Earth's last true frontier. In fact, we've mapped large parts of the Moon and Mars in greater detail than this hidden world beneath our own oceans. Down here, the water stays just above freezing, between 1 and 4 degrees Celsius. Sunlight disappears thousands of meters above you, leaving this world in complete darkness for hundreds of millions of years. And without sunlight, there are no plants, no algae, and no photosynthesis. The process that produces food and powers almost every ecosystem on Earth. So if anything really could survive down here, what would it eat? The entire hadal zone depends on something called marine snow, a slow rain of dead plankton, tiny organisms, waste, and other organic material drifting down from the surface. But it's an incredibly long trip. As those particles sink for weeks, bacteria consume most of them along the way. By the time they finally reach the bottom, less than 1% is left. Occasionally, a dead whale or a large fish sinks into the trench, creating a massive food source for anything nearby. But those events are incredibly rare. Most of the time, almost nothing reaches the bottom. So, based on everything scientists knew about biology, physics, and how life gets its energy, the conclusion seemed obvious. The Mariana Trench shouldn't support complex life. At best, it was expected to be a biological desert with only a few scavengers barely surviving. But there was just one problem with that conclusion. Since its discovery in 1875, nobody had actually seen the bottom of the Mariana Trench to know whether any of it was true. The first descent. January 23, 1960. For the first time in history, humans attempted to reach the deepest place on Earth. Swiss engineer Jacques Piccard and U.S. Navy Lieutenant Don Walsh climbed into the bathyscaphe Trieste, a deep-diving vessel built for a mission no one had ever completed before, reaching Challenger Deep. As Trieste slowly disappeared beneath the surface, the pressure kept rising. Every 10 meters added another atmosphere of pressure. By the time they reached the bottom, the submersible was surrounded by more than 1,000 atmospheres, or about 16,000 pounds per square inch, enough to crush a standard submarine in an instant. Then, nearly halfway through the descent, something happened. At around 9,000 meters, a loud bang echoed through the cabin. One of the outer plexiglass window panes had cracked under the extreme cold and pressure. Fortunately, the inner pressure sphere remained intact, and the descent continued. Exactly 4 hours and 47 minutes after leaving the surface, Trieste finally touched the bottom of Challenger Deep, but the mission didn't go as planned. The moment the submersible landed, it stirred up the soft seafloor, creating a thick cloud of silt. With almost no currents to clear it away, visibility dropped to nearly zero. After spending only about 20 minutes on the bottom, Piccard and Walsh began the long journey back. When they returned, the mission was celebrated as a historic success. Humans had finally reached the deepest place on Earth. But the reality was very different. First, it showed engineers just how unforgiving those depths were. Even a small failure could cost the entire mission. Second, it revealed almost nothing about what actually lived there. So for the next 52 years, no human returned to Challenger Deep. The deepest place on Earth remained almost as mysterious as it had been before that dive. Now, you might be wondering, if humans couldn't go back, why not send robots instead? Scientists did. But those robots could only make short visits before returning to the surface. Staying at those depths for long periods was simply too risky. Japan's Kaiko reached the bottom in 1995, collecting valuable samples during several expeditions. But in 2003, it was lost at sea when its cable snapped during a storm. America's Nereus also reached Challenger Deep in 2009, but 5 years later, it was destroyed by the immense pressure while exploring the Robotic Trench. Again and again, scientists were reminded that reaching the bottom wasn't enough. They needed a way to stay there long enough to see what was really happening. So eventually, scientists came up with a surprisingly simple idea. They built pressure-resistant camera landers, heavy steel frames carrying high-definition cameras, bright lights, sensors, and pieces of fish as bait. Then, they lowered them nearly 7 miles to the seafloor and left them there for hours, sometimes even days. And for the first time, the footage they brought back completely changed what we thought we knew about the deepest place on Earth. Witnessing the impossible. In the early 2000s, marine biologist Dr. Alan Jameson and his team began deploying these landers across the Mariana Trench and other deep Pacific trenches. What the cameras recorded was unlike anything scientists had expected. For decades, scientists had imagined the hadal zone as a place where almost nothing happened. But within minutes of the cameras reaching the bottom, movement appeared from the darkness, then another, and another. Soon, the bait was surrounded. Hundreds of shrimp-like crustaceans called amphipods rushed in from every direction. Some of them grew to nearly 30 centimeters, far larger than their shallow water relatives. Guided by an extraordinary sense of smell, they could detect food from astonishing distances in complete darkness. And once they found it, they wasted no time. They fought over the bait, pushed one another aside and tore through it with powerful jaws. In just a few hours, they could strip an entire fish down to the bone before disappearing back into the darkness. This shocked the scientists. For decades, they believed only a few isolated scavengers could survive here. But the animals they were watching weren't struggling to survive. They were feeding, competing, and behaving like a thriving community, perfectly adapted to one of the harshest environments on Earth. But these unusually large amphipods weren't the only surprise. The deeper scientists looked, the more impossible the Mariana Trench seemed to become, because what the cameras captured next was something many scientists believed shouldn't have existed at all. The fish that broke biology. For decades, marine biologists believed fish simply couldn't survive below about 8,000 meters. No expedition had ever filmed one deeper than that. And the reason wasn't a lack of food. It was biology itself. At those depths, the pressure becomes so extreme that it can begin to change the shape of proteins, the tiny molecules that keep every living cell working. When those proteins stop working, the entire body starts to fail. Even the flexible outer walls of cells become stiff, making it difficult to move nutrients in or waste out. In other words, scientists believed there was a hard limit, beyond which a fish simply couldn't stay alive. Then, in 2014, everything changed. During an expedition to the Mariana Trench, researchers recorded a small, pale fish swimming freely at a depth of 8,145 meters. It wasn't struggling, it wasn't hiding in the mud. It was calmly moving through a place where no fish was supposed to exist. When scientists studied it, they realized it wasn't just a new species, it was an entirely new answer to an old question. In 2017, the fish was officially named Pseudolaparus swirae, better known as the Mariana snailfish, after Herbert Swire, an officer aboard the HMS Challenger expedition that first discovered the trench in 1875. It looked nothing like the terrifying monsters often imagined in the deep sea. It was small, almost transparent, with soft skin and no scales. You could even see some of its internal organs through its body. So, how was it surviving? Marine biologist Dr. Mackenzie Geringer found the answer inside its cells. The fish was packed with an unusual molecule called TMAO, short for trimethylamine N-oxide. Think of it as a microscopic bodyguard. It helps protect the fish's proteins from being crushed out of shape under the enormous pressure. This was the missing piece scientists had been looking for. For the first time, they understood how a fish could survive at pressures once thought impossible. But the Mariana snailfish wasn't the end of the story, because below the snailfish, nearly 2 more kilometers of ocean still remained before reaching the floor of Challenger Deep. And what scientists found there proved that life doesn't simply stop when fish can no longer survive. It just takes on completely different forms. The hidden ecosystem. As scientists explored deeper, they found an entirely different world, one that didn't depend on fish at all. Scattered across the seafloor were strange, delicate structures that looked almost like underwater plants. But they weren't plants. They were xenophyophores, giant single-celled organisms that can grow nearly 10 centimeters across, making them some of the largest single cells ever discovered. Their fragile shells became tiny shelters for even smaller creatures, creating entire neighborhoods on the seafloor. Not far away, pale sea cucumbers slowly crawled across the mud, constantly swallowing sediment and filtering out every tiny bit of organic material they could find. They were, in a way, the cleaners of the trench floor. Then there were vast patches of bacteria and other microscopic organisms covering rocks and sediment. Instead of simply existing there, these tiny life forms were constantly recycling nutrients and helping support everything around them. The deeper scientists looked, the clearer one thing became. The Mariana Trench wasn't just home to strange creatures, it had its own functioning ecosystem. And it wasn't even the same everywhere. Some areas were flat plains covered with soft sediment. Others were steep rocky cliffs or deep cracks in the Earth's crust. Each environment supported a different community of life. Then scientists realized something even more surprising. Maybe the trench wasn't surviving on scraps alone. Its steep, V-shaped walls act like a giant funnel, concentrating sinking organic material onto the seafloor. Dead fish, occasional whale falls, and huge pulses of marine snow all collect in the deepest parts of the trench, providing far more food than scientists had once imagined. And in some places, bacteria weren't waiting for food from above at all. They were creating it. Using a process called chemosynthesis, these microbes turned chemicals like methane and hydrogen sulfide, leaking from cracks beneath the seafloor, into energy without a single ray of sunlight. In other words, they were producing food in complete darkness. By now, the old idea of a lifeless ocean floor had completely fallen apart. The Mariana Trench wasn't just a place where life managed to survive. It was a complete world, running by its own rules. But the question is, did we discover all of this using only those lander cameras? The answer is no. Humans eventually made the journey to Challenger Deep themselves. And the most shocking thing they found on the seafloor wasn't another bizarre life form. It was something else entirely. The deepest human footprint. 52 years after the Trieste mission, humans finally returned to Challenger Deep. On March 26, 2012, filmmaker James Cameron became the first person to make a solo dive to the deepest place on Earth, aboard the deep-sea Challenger. For nearly 3 hours, he explored the floor of the Mariana Trench, capturing some of the clearest footage ever recorded from those depths. But the dive wasn't without problems. The immense pressure damaged part of the submersible's hydraulic system, preventing Cameron from collecting many of the biological samples he had planned. But his cameras still recorded tiny amphipods crawling across the sediment and strange microbial mats spread across the seafloor. Then, 7 years later, another expedition pushed the exploration even further. In 2019, retired U.S. naval officer Victor Vescovo descended to 10,928 meters aboard the titanium submersible limiting factor, setting a new record for the deepest solo dive. He spent nearly 4 hours exploring the seafloor, capturing some of the highest definition footage and helping produce the most detailed maps of Challenger Deep ever created. The cameras revealed pale sea cucumbers, swarms of amphipods, and several strange translucent animals that scientists still haven't fully identified. But one discovery stood out above all the others. Lying nearly 11 kilometers beneath the ocean surface was something that had no business being there: a plastic shopping bag. Nearby were pieces of plastic packaging, including candy wrappers. The deepest place on Earth, a place once believed to be completely beyond human reach, had already been reached by our pollution. Later studies made the picture even worse. Scientists found microplastics inside every hadal amphipod they examined, showing that even this remote ecosystem had become part of the global plastic problem. The same ocean currents that carry food into the trench also carry our waste. For the first time, it became painfully clear that even the deepest place on Earth was no longer untouched by human activity. But while scientists continue to explore and protect the deepest parts of our oceans, another company is using many of the same ideas for a mission that reaches far beyond the Mariana Trench, and even beyond Earth itself. Beyond the Mariana Trench. Today, the Mariana Trench is no longer seen as a lifeless hole at the bottom of the ocean. It has become one of the most important places on Earth for understanding the limits of life itself. Every expedition continues to uncover new species and remarkable genetic adaptations. Scientists are studying these pressure-loving microbes for enzymes that could help develop new medicines, improve industrial processes, and even break down certain pollutants. But perhaps the biggest impact of all reaches far beyond our own planet. The discoveries made in the Mariana Trench are now helping guide missions led by NASA and other space agencies searching for life elsewhere in our solar system. One of their biggest targets is Europa, Jupiter's icy moon. Another is Enceladus, a moon of Saturn. Both are believed to hide vast liquid oceans beneath thick layers of ice. No sunlight reaches those oceans, just as no sunlight reaches the hadal zone. Yet the Mariana Trench has shown that life doesn't always need sunlight. Through a process called chemosynthesis, entire ecosystems can survive by using chemical energy instead. That means if similar conditions exist beneath the ice of Europa or Enceladus, life there may no longer seem impossible. In other words, by exploring the deepest place on Earth, we may have taken one of our first real steps toward answering one of humanity's oldest questions. Are we alone in the universe? And perhaps the most exciting part is that this story is only beginning. More than 80% of the world's hadal trenches still remain unexplored, which means the greatest discoveries may not be behind us. They could still be waiting in the darkness. So here we are. A place once believed to be a lifeless abyss turned out to be one of the most extraordinary ecosystems ever discovered. And it may even hold the key to finding life beyond Earth. And now, after hearing it all, what do you think? What discovery from the Mariana Trench surprised you the most? And if more than 80% of Earth's hadal zone still remains unexplored, aren't we searching for life on other planets too soon? Let me know your thoughts about this in the comments below. If you enjoyed this video, don't forget to give it a thumbs up. And if you want more incredible mysteries, discoveries, and fascinating stories like this, be sure to subscribe to the channel. Thanks for watching, and I'll see you in the next video.